let's look at a real life example of how we can use the slope-intercept form to help us graph what happens in real life. Now if you look at this example here, it says the equations below model the changing speeds of a car as it enters an expressway, travels on the expressway, and then exits this expressway. And it wants us to create a graph to represent the car's different speeds. Okay, so here is the first one entering the expressway. Our S here represents the speed, and our T represents the time. Okay, so for the first 2 minutes, so between 0 and 2, we're entering the expressway at 25 miles per hour, and we're accelerating at 15 miles per hour. Now, I want you to think back to when we talked about slope as a rate of change. And I had said that we can use slope and rate interchangeably. Okay, so if you're looking at slope-intercept form, and I'm looking at this equation here, okay, this is our y-intercept. Okay, this is our slope. This 15 here says we're increasing our speeds at 15, I guess I'm going to say miles per hour, even though it doesn't say it on here. But that's our slope. Okay, so if I just wanted to graph this, and again, you focus on the domain from 0 to 2. Okay, so from 0 to 2, my intercept is 25. So let me just kind of start here with the graph. Okay, these are going to represent our speed, and this is going to represent our time. And if you look at our time here, we're going from 0 to 2 the first 2 minutes, and then we're going to 12, and then up to 14 minutes. And I guess I shouldn't say miles per hour per se, because it's talking about minutes here. Okay, so I need to go up to 14. 2, 4, 6, 8, 10. Yeah, it should be enough. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so I'm going to have my time on my x-axis, and we're going to have our speed on our y-axis. And looks like right here our speed is 55 miles per hour. So let's go up to 55. 5, 10, 15, 20, 30, 40, 50, 60. Now, if it doesn't totally make sense what these numbers are, know that you at least have to graph this equation. We have our y-intercept, which is 25, and we have our slope, which is 15. So my y-intercept is 25, and I'm rising 15. Okay, so our b, our y-intercept, equals 25 from our equation, and our slope equals 15. Again, if I think of it in terms of rise over run, I write it as 15 over 1. Now that doesn't mean we're going up 15 units. Each one of these blocks represents 5. So if I'm going up 15, there's 5, 10, 15, but each one of these lines going to the right represents 1. So I am going to go up 15 over 1. Put it in different colors so you can see it. So from our y-intercept, I'm going to go up 15, 5, 10, 15 over 1 unit. Okay? So I'm going to draw a line from there to there. But now it says we do that for the first 2 minutes. So I'm from here again going to go up 15 over 1. Now what you can see when you extend that line is we end up right there. So for the first 2 minutes, that's what I'm traveling. Notice I didn't put arrows at the end, because this line doesn't continue on and on. First of all, it doesn't make sense for us to deal with negatives. And second of all, at this point here at 2 minutes, I change. Okay, at 2 minutes, now I have S equals 55. Now remember, S is like saying Y. So if we said Y equals 55, hopefully you guys can remember that Y equals is a horizontal line. So now I'm going to draw a horizontal line through 55 from 2 to 12. So I'm at 2, so from this point, I'm going to draw a horizontal line through 55 all the way up to 12. Okay, so see how this first graph represented us getting to 55. Now we're traveling 55 miles an hour, and then finally, we have our next slope here. from this range, from 12 to 14. Now notice it's negative. Negative, remember, means it's going to be going down. It's going to be going down negative 15 over 1. So for 2 minutes, we are going to go down 5, 10, 15 over 1. For 2 minutes though, so 5, 10, 15 over 1, put it here. But if you draw a line through it, it represents us decelerating. Okay? So what this graph here shows us, oops, is what's happening as we drive. Oops. Okay? For the first 2 minutes, our time here, we're accelerating up to speed. We're accelerating at a rate of 15, must be miles per second or something, okay? Or feet per second, whatever. And then we're going to stay at a constant rate. That was our s equals 55 here. We're going to stay at 55 miles per hour all the way up until 12 minutes, and then we decelerate for 2 minutes, a rate of 15 over 1, negative 15 over 1. So we go down 15 over 1, down 15 over 1. And what this graph does here is it represents these 3 equations, okay? The acceleration, the remaining steady, and then our deceleration. Now notice here it says our y-intercept is 235, and we didn't take that into account. If we extended this line all the way up over here, you'd see it does hit the x-axis at 235. But we're not concerned with that. We're only concerned with the time they gave us. Okay, so again, this looks a little different than what we're used to. It's a different type of graph than what we're used to. But what we're doing is we're graphing the same way. Paying attention to the stages we're given.